Good afternoon, friends. Now we are discussing optimality test using Modi method. So Modi modified distribution, modified distribution, DI. So in module number 3 of transportation problem in the subject operation research. So optimality test. So using any method we have learnt like least cost method, northwest corner element method, row minima method, column minima method, or Vogel's approximation method WAM, we find the initial basic solution for the given transportation problem. Then applying optimality test to check whether the solution obtained is optimal or not. That is any improvements we have to reduce the transportation cost. So for this particular transportation problem, the initial step we apply is to check whether the problem is balanced one or not. Since the summation of demand is not equal to summation of supply, so that is summation of demand 215, summation of supply 195. So it is unbalanced problem. So convert the problem into a balanced TP, that is transportation problem, by adding the dummy row here. So that is O4, because we have 4 columns but 3 rows. So we make the fourth row to get entered. So dummy row with all the costs 0. So it is the same as original problem given. Now the difference of demand and supply is now 20. So that will be added as supply here. So then using Vogel's approximation method, so the initial basic solution is obtained here. So the allocations were made like this. Now we have 7 independent allocations here, 1, 2, 3, 4, 5, 6, 7 and m plus 1. So 3 rows and 4 columns. So we have m plus n minus 1. So that is 3 plus 4, 4 rows, 4 columns, 4 plus 4. So that is 8. 8 minus 1 is 7. So allocations are also 7. So the solution obtained is non-degenerate solution. So total transportation cost comes to 65 into 6 plus 5 into 1, so on it goes. So it comes to 1010. Now we are applying Modi method. So the first step is to find out U and V values. So U will be written at the end of each row and V will be written at the end of each column. So we will find a set of numbers Ui and Vj. So for which U plus V is equal to C, that is the cost. Ui plus Vj is equal to Cij for each occupied cell. So for each occupied cell. So the first occupied cell is cell number 1 having the cost of 6. So U plus V should be equal to this cost 6. So I make U as 0. So U plus V is 6. So if U is made 0, V becomes 6. So U is written as 0, V will be written as 6. So then we'll move on to the next occupied cell, that is cell number 2 here, that is also occupied. So the cost is 1. So U plus V is equal to 1. So U is already made 0. So V becomes 1 now. So the next occupied cell is here, O2, D2. So the cost is 5. So U plus V is equal to 5. So V is already written as 1. So we make U as 4. So this becomes cost is 5. So 4 plus 1 is 5. So the next one is this occupied cell with the cost 2 here. So we have u plus v is equal to 2. U is already 4. So v will be made as minus 2. So 4 minus 2 becomes 2. So then the next occupied cell is here. So that is 25 is the allocation. The cost is 4 there. So already we have written as minus 2. If you make u as 6, so that becomes 6 minus 2. So that is 4. So we'll write u as 6. So then the next occupied cell is this here 45. The cost is 7. So already u is written as 6. So if we make v as 1, so 6 plus 1 is 7. So like this we fill the u and v values. So u plus v is equal to cost. Now take the sum of u and v for each empty cell and write at the bottom left corner. So that is u and v for each empty cell. So and write at the bottom left corner. So for each empty cell. So this is empty cell. So u is 0, v is minus 2. So we are writing minus 2. So u is 0, v is 1. So we write 1 here, bottom left corner of empty cell. So 4 here, 1 here. So 4 plus 1, 5. We write at the bottom left corner. So all empty cells will be filled like this. So minus 6 plus 1. So it becomes minus 5. So we write at the bottom left. So all the empty cells bottom left will write the sum of u plus v. Then in the bottom right corner we will find the net evaluation delta. That is cost minus sum of u plus v. So sum of u plus v is written in the bottom left. So from the cost you subtract that value and write in the bottom right in each empty cell. So 9 minus of minus 2 becomes 11. 3 minus 1 becomes 2. 0 minus of minus 5 becomes 5. So we are writing delta value in the bottom right corner of each empty cell. So delta ij we are writing at the bottom right corner. Now if all the delta values written on the bottom right corner are positive means we'll have that allocation. Otherwise the condition is not satisfied. The solution is not optimal because here so one of this delta value is minus 2. So that is non-negative. So we have to proceed further. So the cells 3, 1 has most negative value of delta ij. So that is if we have more than one cell having a delta value with a negative sign, so you take the most negative one. But here we have only one negative sign here, so that is O3D1. So then improve the allocation by making this cell as the allocated cell. We will draw the alternate, so we will start writing the loop here starting from this, and you make sure that all the corners are the occupied cells and complete the loop. So take the minimum out of these. So we are drawing the loop here. So delta value is negative here. So that is the only one cell where my delta is negative. So that is minus 2 in the empty cell. So Draw a closed path by assigning plus and minus sign alternatively from this cell such that we have occupied cells in the corner. So we start from here. So start writing the loop. So go up. So and here we are taking right turn here because we cannot go further upwards. Now this is occupied cell. So come horizontally. We cannot proceed further because there are no occupied cells further. So this is occupied cell. So come down. So we stop here because no further occupied cells beyond this. So stop here, go horizontally, then come down and then join back. So now make sure that all the corners of this loop are occupied cells. Start assigning plus and minus sign starting from here, plus minus plus minus plus minus. So then from the cells having minus sign in the corners, take the minimum one. So we have 65, 30 and 25. These three are having minus sign. So taking minimum out of these three, 65, 30 and 25. So that is 25. So add this 25 at the cells having plus sign and subtract 25 at the cells having minus sign. So minus sign where it is there. So subtract 25 from 65. We will have 65 minus 25, 40. Here plus sign is there. So plus 5 means 25 plus 5 becomes 30. So wherever minus sign is there in the corners, subtract 25. Wherever plus is there, add 25. So here this is not allocated earlier. Now 25 will be allocated here. So 25 is allocated here. So this is the final allocation with the improvisation. Now the cost will be now 40 into 6 plus 30 into 1 plus 5 into 5 plus 50 into 2 plus 45 into 7 plus 25 into 10 plus this is 20 into 0. This is the final allocation. Thank you.